So we're given this window that's got a semicircle on top. I've labeled the height y, the radius of this semicircle on top is r, but we know what r is. R has to be half of x. So, and we're told that the perimeter is 8. We'd like to maximize the area. That will maximize the amount of light that's coming in. So let's first figure out a formula for the perimeter, since that's equal to 8. We're going to have to set that equal to 8. So the perimeter is the sum of all the sides. So we've got an x on the bottom, we've got two y's, and then we've got that top part, which is half a circle. So the equation of for the circumference of a circle is 2 pi r, but this is half a circle, so it would just be pi r. So we get pi times r, but r is half x. Okay, so we can then write this as x plus 2y plus pi over 2x. Okay, so this has to be equal to 8. Alright, and then the area, that's the thing that we're trying to maximize. The area is the area of the square part, so the square part is just going to be x times y. And then the area of the semicircle, for a semicircle, it's the equation is, well, it's normally pi r squared, but this is half a circle, so 1/2 pi, and then again it's r, which is 1/2 x, so 1/2 x squared. We can simplify this. The 1/2 squared is 1/4 times the 1/2 that's already there, so we're going to get xy plus 1/8 pi x squared. Okay, now we need to eliminate one of these variables here, specifically the y variable, so we can come back up here to our equation for perimeter, solve that thing for y. So we're going to get, let's see, 2y is equal to 8 minus x minus pi over 2x. So we'll simplify this term. We'll get y. We'll have to divide everything by 2 first, so we'll get 4 minus 1/2 x minus pi over 2 x. Now these, sorry, that'll be pi over 4x. Let me fix that. Pi over 4x, dividing everything by 2 there. And then, well, these are like terms here, so we can combine them. So we're going to get 4 minus 1/2, and then it'll be plus pi over 4x. And so I factored out the x, and now we'll go ahead and combine these two terms. So we'll get y is equal to 4 minus, let's see, the common denominator is 4, so that'll be 2 minus pi over 4. That's the coefficient, and then x. Okay, so that's what y is equal to. Now we need to plug that in for the area equation, so we can get area as a function of x. So the area is going to be x times y, which is what we just found, so 4 minus 2 minus pi over 4 x. Actually, these should all be pluses, right? This is 2 plus pi, 2 plus pi. There's a plus right there. Okay, and then let's see. We still have our plus 1/8 pi x squared. Okay, so this is the equation that we need to find the derivative for, but before we do that, let's go ahead and distribute that x. So we'll get 4x minus 2 plus pi over 4 x squared plus 1/8 pi x squared. Okay, so now we've got like terms again. These are both x squared terms, so let's simplify this a little bit more before we take the derivative. So we get 4x minus, we'll have the 2 plus pi over 4, and this will now become minus 1/8 pi x squared. Okay, so I factored the x squared out of here and really also factored out a minus, so that's what we get. Let's go ahead and combine these, so we'll get a nice single term coefficient there. So we'll get 4x minus, the coefficient now will be, the common denominator here is 8, so we'll have to multiply that by 2, so we'll get 2, we'll get 4 plus 2 pi minus pi over 8 x squared. And then we have like terms there, so we can go one step further, get 4x minus, coefficient now will be 4 plus pi over 8 x squared. So now we're ready to take the derivative, so a prime of x will be 4 minus, now when I bring that 2 down, it's going to cancel with the 8 and become 4, so we'll get 4 plus pi over 4x. And now we'll want to set that equal to 0. So I can move one of the terms to the other side, so that one term is just equal to the other, so we'll get 4 plus pi over 4x is equal to 4. So to solve this for x, I'll just multiply by the reciprocal of that term there, so we'll get x is equal to 16 over 4 plus pi. And remember with WebAssign that we want all the answers to be exact, meaning that we do not want to do a decimal approximation on that, unless the problem actually specifically tells you to round it. So this will be the x value that you actually want to enter.